Okay, this is Hunter Vogel explaining part 2, question 2, number B and C. Okay, so first let's go over what the quantum numbers are. N corresponds to the number that is next to the letter. That's just how I remember it. L corresponds to the letter itself. So when L equals 0, that's the same as S. And for L equals 1, that's P. For L equals 2, that's D. For L equals 3, that's F. So it's just another way of writing those letters. ML just corresponds to which orbital in the subshell it's in. And MS corresponds to the spin on the electron. So it's either up or down, which is positive 1/2 or negative 1/2. So that's what the quantum numbers are. So B asks you to just fill out this chart here. Ask you to say the maximum number of electrons that have these quantum numbers. So N equals 4. How many electrons can have an N equals 4? So remember, there's a 4 S. There's going to be a 4D. There's going to be a 4F. And there's going to be a 4P. I said that out of order, sorry. But for the 4S, that's 2 electrons plus 6 for the 4P plus 10 for the 4D, and then plus 14 for the 4F. That's going to give you 32. The answer there is 32. Yep. Okay. Then N equals 5, ML equals plus 1. So, if N equals 5 and ML equals plus 1, we can disregard the 5S subshell, because those always have ML values of 0, because there's just one orbital in the middle notated as 0. So there can be 2 electrons in the 5D that have an ML of plus 1. There can be 2 electrons in the 5P that have ML plus 1. And then there can be 2 electrons in the 5F that have ML equals plus 1. And then that equals 6. That's the answer. Okay, this one says how many electrons can have N equals 2, L equals 2, and we don't even need to read the rest of this part, because already we know the answer is 0, because this makes absolutely no sense. Because if L equals 2, remember that corresponds to a D subshell, and the D subshells start at N equals 3, so this makes no sense. And then N does equal 3 when L equals 2, so now we're on to something. And MS equals negative 1/2. Now remember, MS is just the spin on the electron, either plus 1/2 or minus 1/2. So really just dividing by 2 here is what it means. So N equals 3 and L equals 2. That's the 3D subshell. So there's 10 electrons in the 3D subshell. And just divide by 2, and that will equal 5. And that is your answer. Because only half of them can have this negative 1/2 spin, because the other half would have the plus 1/2 spin. Okay, so I'm going to try to keep this all in frame here. Right, question C just tells you to answer the following about the ground state of arsenic. Right. Ground state of arsenic. How many electrons have L equals 1 as a quantum number? Remember, L equals 1, that just corresponds to the p orbital. So basically they're asking, or p subshell rather, basically they're just asking how many electrons are there in p subshells in arsenic. So there is the 2p subshell, that's 6, plus the 3p subshell, 6, plus the 4p subshell, which is only half full, that's 3, so that equals 15, and that is our answer. Yep, okay. Then it asks, how many electrons have a ml equal to 1? So remember, ml equals 1 just means the position, the orbital in the subshell. So if ml equals 1, we can disregard all the s subshells because those always have an ml value of 0 because there's only one of them. So how many have ml equal to 1? We're working with p and d subshells here because we're disregarding those s subshells. So how many can have the ml1 in the 3D is 2, plus 2 for the 2p, plus 2 for the 3p, then just plus 1 for the 4p, because remember, it's only half full. So that equals 7, so that is our answer, 7. Okay, and the third part asks, how many electrons have ml equal to 0? All right, so now it's basically the same, but we're counting the s subshells now, because those actually can have an ml equals 0 value. So 2 plus 2 plus 2 plus 1, just like before, but now we're adding another we're adding another 4 2's to this equation because of the 4 s subshells. So 2 plus 2 plus 2 plus 2 equals 15. So the answer is 15. Okay, and the last part of this whole thing says, for the last electron added in the Aufbau process, what are these quantum numbers? Okay, the last electron added, you can't really see this. Okay, the last electron added is this one here. So we're just talking about that electron. Okay, so what is its n value? 4. What is its L value? Remember, it's p, so that's going to be 2, right? Yes. No. It's 1. Good thing I checked. You should always check. ML, remember, that's just the position in the orbital, in the subshell. It's the orbital in the subshell. Plus 1, because this is 1, 0, negative 1, 0, plus 1. That's how you label the orbitals. Okay, and then MS value is equal to, it's the upspin. You do those first. Doesn't really matter, but it's just convention according to the Aufbau process. So the upspin means it's plus 1/2. And that is the answers. Okay.